Our exponential function. Let's see how we do calculus with it. We've seen how we did calculus with polynomials, but what about the exponential function? So we'll go back to first principles. So function x would be our a to the power of x. Function x plus h then is a to the power of x plus h. Put it into our first principles formula and we get this. Limit as h approaches 0 of a to the power of x plus h minus a to the power of x. Okay, well I could factorise the a to the power of x, but that leaves me with a to the power of h minus 1, and I'm going to have that 0 on 0 problem still. So how can I fix this one up? So let's just look at that particular limit. A to the power of h minus 1 over h, which I could rewrite like this. A to the power of 0 plus h minus a to the power of 0. Why do that? Well, that is now the first principles formula for the derivative at 0, because we've got it in the form x plus h minus function x. So in other words, I know the answer to this limit will be the slope of the tangent at x equals 0, whatever that is. So here's the formula. If function x is equal to a to the power of x, then its derivative will be m times a to the power of x, where m is the slope of the tangent at x equals 0. Let's have a look at Euler's number, that wonderful irrational number e. There's the actual definition of it. The limit as n approaches infinity of 1 plus 1 on n all to the power of n. So the bigger and bigger n gets, the closer and closer it'll be to the value of e. You plug it into your calculator, you get something like this, 2.718281828. Looks like it's a repeating decimal, but it's not. It's just the screen of your calculator is limited to that. If you were to keep going, you'd see that pattern stops. But anyway, the exponential function base e has a slope of 1 at x equals 0. This is something we know. So therefore, if I was just differentiating e to the power of x, and I know the derivative at 0 is equal to 1, then the derivative is also e to the power of x. It is no different. In other words, what we're saying is the slope of the basic exponential function is equal to the height of the curve above the x-axis, or the y value if you like. So the y value of that basic exponential curve will always be the same as the slope of the curve at that particular point. So what we're saying is f dash x is actually equal to the y value. Find e to the power of 3, or we'd use our calculator for that of course, and you should get 20.086. If you had to draw an exponential, 5 minus e to the minus x, well, basic curve, e to the power of x. There it is. What have we done to it? Well, function negative x means reflect in the y-axis, so let's do that. Then we've also got minus function x, which says reflect in the x-axis. We'll do that as well. And then finally, we've shifted the whole thing up 5 units. And there's our curve. That is all for today.